Alrighty, guys. So we're going to do a little bit of practice with simplifying and giant ones. You guys have seen the giant one already. And then we're just going to put this into practice, right? And this is really useful, especially when we're simplifying fractions, because simplifying just means that we're taking the bigger numbers and we're making it smaller for ourselves so that we can use it while keeping the same value. Okay, so let's go ahead and label this this in our notebook, the next clean page. We're going to put giant ones and equivalent fractions. All right, equivalent fractions, right? And we remember that equivalent means equal or the same. Okay, so set up your notebook, the topic and the date. I just put the topic and that's okay. And we're going to go through these slides, okay? So looking at this, it says, look for the giant one that will make the denominator 100, right? And so we're going to put example number 1 here because these are not from our book, right? And let's go ahead and copy this down 3/5, right? Times some number, and we'll give myself extra space, and it has to be a fraction, equals 100 in my denominator, okay? So denominator is the bottom number, numerator is the one on the top, okay? So it says, look for the giant one that makes the denominator 100. Now, we want to know really quickly, how do I go from 5 to 100? What do I multiply by, right? Remember that dot means to multiply. And if you can't quite think of what to multiply, because it's kind of like you have to either know or you're trying to guess at the same time, right? If you don't know what 5 times something equals 100, we just work backwards, okay? So the easiest way to do this is to start backwards with our 100. We're going to go 100, and instead of multiplying, right, we're going to do the opposite, which is divide by 5. And when we do this, tell me what you get. This one should have gotten 20, right? And so we look at this. I put 20 in my denominator, right? 5 times 20 equals 100. If I do it to my denominator, I have to do it to my numerator as well. 20 over 20, right? Because that's where the giant one comes in. And then now I can multiply straight across. So going straight across, 3 times 20 gives me 60. And it says to use the percent symbol to rewrite the fraction as a percent. And when I look at this, right, percents are always out of 100. So this will give me 60 over 100, which equals 60%, right? 60 hundredths. And then you can write your decimal too. Okay, so 20 over 20 is our giant one, right? This makes 20 divided by 20 equals 1. And then it gives me 60 over 100, or 60%. Okay, let's move on to the next one. Okay, so it says these are helpful. Copy them into your notes. So we're going to go ahead and copy them in. And I believe, let's see if we can do it faster than the timer, right? Oops. With time to spare. That was loud on my end. Okay, so when I look at this and I have something useful in my notebook, I like to draw attention to it, right? So you can put a box around it, you can highlight it. What I like to do, I don't know why I always do this, but I just put clouds around it. And it just brings attention. You could put stars, you could put stickers, anything. But when you have notes, there's so much writing and usually it's so condensed. One, we want to have good spacing so it doesn't look like everything's cramped. And then two, we want to make sure we draw our eyes to certain things when we review our notes. Okay. So let's go ahead and go to the next one. It says copy each problem and use a giant one to convert the fraction to a percent. So let's go ahead and I'm going to do the first one with you. And again, remember you can pause at any time. So we're going to do number one. Number one, right? And our first one is 7/10 times something, right? Equals over 100 or something percent, right? And again, the way I'm looking at this, remember all of these, we want it to be over 100 and we can use our notes that we had here to do it, okay? So going from 10 to 100, I'm like, I can't think of what times 10 equals 100, so I can work backwards. 100 backwards, the opposite of multiplying is to divide, and then by 10. So it's this 100. Instead of multiplying, we divide, and then the 10 we're using is this one, right? Still our denominators. This gives me 10. This means our multiplier is 10. If my denominator is 10, then my numerator on the top is 10. This gives me my giant 1, okay? Right? And then I just multiply straight across, right? So 10 times 10 in my denominator is 100. 7 times 10 in my numerator is 70. I know that percents are always out of 100, so this will give me 70%. Okay, go ahead and pause. Pause and then complete 2, 3, and 4. And then when you are done, enter it in and check your work with me. Okay, go ahead and check your work here. So looking at this one, 3 over 25, right? And then you're looking, how do I go from 25 to 100? We multiply by 4. If I do it in my denominator, I have to do it to the numerator. 3 times 4 is 12 or 12%. For number 3, how do I go from 20 to 100, right? Working with our denominators, we multiply by 5. And then if I do it to my denominator, I do it to my numerator. 17 times 5 gives me 85 over 100 or 85 hundredths or 85%. And then the last one, 8 over 5, right? So how do I go from 5 to 100? We multiply by 20. So 8 times 20 is 160 or 160%. And I'll know a lot of students, they'll be like, oh my God, 160%, that's more than 100. And then they'll freak out, right? But just take a deep breath and we look at 8 is bigger than the 5, right? That means it's more than a whole, like if you're thinking about like slices of pizza or fractions or a bar or something like that, right? 8 is bigger than 5. That means it's more than 100%. There's more than those 5 slices. Okay. And I also wanted to note number 3. This is when I use generic rectangles kind of in my mind, right? So 17 times 5, can't do it straight away in my head, right? But I can do 10 times 5, which is 50. I can do 7 times 5, which is 35. And 50 plus 35 gives me that 85. Okay, so that's just practice. Right. So let's go ahead and check our work. Right? And looking at this, we've got 70%, 12%, 85%, and 160%. Okay, part 2 to this section. And again, you can pause whenever you want. Part 2 is simplifying fractions, right? And then we're going to show you 2 methods on how to do this. So I'm going to write simplifying fractions. And this is very important. We use this all the time, and a lot of my students in 7th grade are still struggling with simplifying. Okay, so a fraction is simplified in the lowest terms when the numerator, the top number, and the denominator, the bottom number, do not have any common factors. right? So it says write the fraction as a product of factors. Look for common factors, right? The ones they have in common. So if I do example 1, right, and I have 16 over 36, I can break this down. I can break down 16 into 4 times 4, right? I can also break down 36 into 4 times 9. And what you're looking for is, what do they have in common? What they have in common right here is this giant 1, right? So I can simplify that by factoring it out and then seeing what they have in common. And then when I simplify this, this will end up with 4/9. Now, if I break down 4 and I break down 9, they will not have anything in common. And I'll show you with the bottom one. Okay, 16 and 36 can also be broken down. So if I have this 4, right, this 4 can be broken down into 2 times 2. This 4 can be broken down into 2 times 2. Now, if I multiply all of these, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So if I multiply all of that, that gives me 16. These are my prime factors, okay? From 36, I can break this down. The 4 can break down into 2 times 2. The 9 right here can be broken down as 3 times 3. So if I multiply all of these in the bottom, 2 times 2 is 4, times 3 is 12, times 3 is 36, and that gives me that number, right? Here what I have are giant 1s and giant 1s, and then I can see that they have nothing else in common, right? And they have nothing else in common. Now I just multiply what's left. 2 times 2 is 4, 3 times 3 is 9, and that is going to be my simplified answer, right? So those are my giant 1s. Okay. Okay, method 2. This is actually my favorite method, or I guess the one that I was taught when I was younger. So here, let's go ahead and do example 2. Example 2. And it says, example 2, well, I guess we can write out. So number 1 is factoring, right? And number 2 is divide the numerator and the denominator by what they have in common, okay? And it says the fastest way is to use the greatest common factor. Now, for me as a math teacher and has taken a lot of math classes in my life, I still don't do it with the greatest common factor sometimes, right? I feel comfort in doing it by smaller numbers, and it takes longer, right? But at least I feel comfortable with that, okay? So let's do this. If I have 16 and 36, some of you may know that you can divide, right? I can divide both the numerator and the denominator by 4 over 4, which is the same thing that we did here, right? 4 over 4. Here is my giant 1, right? Notice that this is a giant 1. If I'm dividing by 1, I'm not changing the value at all, right? I'm just simplifying. So another way to rewrite it, still keeping the same value, right? So 16 going straight across, 16 divided by 4 is 4, 36 divided by 4 is 9. Now, for those of you who don't feel comfortable with that, if I take 16 and 36, what I do know, and this is me as a math teacher, I know that they're both even numbers. If they're both even numbers, I can definitely divide by 2 over 2, right? I can divide by 2 over 2. This, looking at this, gives me 18 divided by 2, or sorry, 18. 16 divided by 2 is 8. 32, I can't talk. 36 divided by 2 is going to give me 18. And oh, look, they're still even numbers, which means I can still simplify even more. If I divide by 2 over 2 again, look, giant 1, giant 1. If I divide by 2 over 2 again, I will get 8 divided by 2 is 4, 18 divided by 2 is 9, and that is my simplified fraction because I can't divide anymore, right? So you can pick whichever one you want. This one is really nice because when you get to your factoring, and we've done toolkits with factoring before, but when you get to this, then you know it's simplified. Sometimes with example 2, when I'm just dividing by things, sometimes I'll get to an answer which I think can't be divisible by anything anymore, but it could still be. All right, so looking at this, 16 divided by 4 is 4, 36 divided by 4 is 9, and this one, it's just taking it a couple more steps, right? And it's just whichever one you feel comfortable with, right? Because we end up with the same answer. Okay. All right. So these are your practice problems. It says copy each problem and find a giant 1 to write the fraction in lowest terms. Our first one, right, we'll do together. So let's see. I need another page. Okay. My first one is going to be 21/30ths, right? And it says if I factor this, something times 7 and something times 10, right? So then I'm like, okay, well, if I don't know what to multiply to get 21, I work backwards. 21 divided by 7 gives me 3. On my denominator, that's 10. That should be 10. Why aren't you guys catching me? Just kidding. All right, so if I do this, 30 divided by 10 gives me 3, and these are my giant ones, right? So if I factor this out, if I simplify, right, this will leave me with 7/10. Okay. The other way you can do this, I want you to write this right underneath, is 21/30ths, right? If I divide, right? So I know that I can divide both 21 and 30 by 3. And I just go straight across, right? 21 divided by 3 is going to be 7. 30 divided by 3 is going to give me 10, and that is my simplified fraction, right? Smaller fractions. And you're like, why do I have to do this? It helps you work with them when we get into later problems, right? So working with smaller numbers, I believe that there's less room for mistakes because you are comfortable with smaller numbers. Okay, so go ahead, we're going to pause this, and then you are going to do 2, 3, and 4 and simplify those, and then come back to us. Okay, here we go. So on the PowerPoint slide, they show how you break it down, how you factor it, that first method, right? So 24 can be broken down into 6 and 4. And then 66 can be broken down into 6 and 11, ways that you can factor that. And if you have smaller numbers, that's okay too, right? 35 can be broken down into 5 and 7. 100 can be factored into 5 and 20. And then number 4, this one, I actually think that this method is actually better than the dividing, because for me, I need to be able to see what you can divide by, right? So 26 can be factored into 2 and 13. 39 can be factored into 3 and 13. And then you create your giant ones. Here on this side, I just divided, right, by my giant ones. So dividing by 6/6 gives me that same answer. 35 and 100, I know that you can divide them both by 5 because this ends in a 5 and this ends in a 0. And then number 4, they can both be divided by 13, and you just divide straight across. Last practice problem, show what you know in the snow, go. So it says use giant ones, write the fraction in lowest terms, then convert your new fraction into a percent, right? So what that means is simplify and then get it into a percent. So using both things that we learned, simplifying it and then making it go out of 100, okay? Go ahead and try that. Okay, so last problem, simplifying my fraction, whichever way you did it, right? 27/60, I know that I can divide them both by 3. And the trick is this, right? When you add, I think I learned this in 6th grade, when you add these digits together, it can be divisible by 3, right? 2 plus 7 is 9, that you can divide by 3. 6 plus 0 is 6, that you can divide by 3. So those are little tricks on how to do that. I can divide by 3/3. This is my giant 1. And this will give me 27 divided by 3 is 9. 60 divided by 3 is 20. Okay. Then using the simplified fractions, we now can go to 100, right? So 20 times 5 is 100, right? We had to figure out how to go from 20 to 100. And then if I do it to my denominator, I have to do it to my numerator. So 9 times 5 is 45, and percents are always out of 100. So this will give me 45%. Okay, so just notice that we can divide by giant ones, we can multiply by giant ones, and all we're doing is just manipulating these numbers, keeping the same value, but manipulating how it's written so that we can get it to where we want it to go, right? Because if I wanted to go from straight from 60 to 100, I'd have to use decimals, right? It does not nicely go to 100. So sometimes we have to work backwards to go forwards. Okay, that is it for this one. And yeah, that's it. Thank you. Get to the end of the video, please.